So the answer to this is 11.5813. 5813, which is, you could say, about 12 years for your money to double, if you round it up. The next one we have, how much money would you owe if you took out a loan of $30,000 after 10 years compounded quarterly with a 3.3 interest rate? So if you're going to college and you have to take a college loan out, you can use this formula to figure out how much you'll owe based on the interest rate and how often it's compounded. So you have A, P, N, R, and T. So pause this video and see if you can determine what each of those variables equal. So here are all of our variables. And this one's really nice because you just have A equals 30,000, 1 plus your interest rate, 0.033, divided by 4 times quarterly. And then you have 4 times 10. And then you can type it in your calculator just like that and get the answer. So 41,672. And if we round to the nearest cent, it would be 59 cents. So that's how much you would owe after 10 years. So if you actually took a $30,000 college loan out, how much you'd pay per month, you'd divide by 10 years if you're paying it over 10 years, and then you'd divide by 12 months per year. So you'd owe $347 per month to pay back your college loan. The next formula is for continuous compounding. It's really important. Anytime you see the word continuous, you're going to be using this formula, which is kind of similar to the last one. The A and the P is still the same, the amount and then the principal P. E is Euler's number. E is a constant, which is approximately 2.7. So we always know what E is, it's a constant. And then R is the rate, the interest rate, and then T is time in years. So if you deposit $150, paying 4%, and notice it says compounded continuously. If you see continuously, you're going to use this formula. How much money will you have after 5 years? So you have A, P, R, and T. So the $150 is your principal. 4% interest is your rate as a decimal. Compounded continuously means you use your E. And how much money will you have after 5 years? 5 is your T when you look solving for A. So you have the amount equals 150 E to the 0.04 times T. And you can get the answer with your calculator, not a lot of solving to do. So 183.21 would be the answer to that. On the next one, see if you could answer this. Again, it's continuous compounding. So you're going to use this formula, A equals P E to the RT. And see if you could figure out what A, P, R, and T, at least 3 out of 4, what those equal. Plug them into the formula and see if you could solve the formula. So you should have your your P value is 100, down right there. Your interest rate is 0.035%. Compounded continuously, you use E. And how long will it take? That's a time question. Your money to double. Double. Double means times 2. So if you started with 100, doubling it, you'd have 200. So you'd have 200 equals 100 E to the 0.035T. And you divide both sides by 100, you'd have 2 equals E 0.035T. And to solve for T, if it's stuck in the exponent, you have to get rid of the base of the E. So you log both sides, but the log that you use is a natural log with base E. So it's ln2. And then ln E cancels, and you have 0.035T. So T equals ln2 divided by 0.035. And when you do that on your calculator, you get this. So there's the answer, 19.8 years for your money to double. And there's the work, ln2, and then divided by 0.035. On the next one, we have a different formula. So the two formulas that I showed earlier, you should memorize those for your test. Other questions, you could be given a formula like this one. So radioactive decay of radon 222 can be modeled by that function, where A is the amount remaining, C is the original amount, and T is time in days. If there's 15 milligrams CO2 in a glass tube, how much will remain after 8 days? So here's the formula, A equals CE to the negative 0.1813T. 15 milligrams is your initial amount, so that's going to go in for C. So 15 is for C. E to the negative 0.1813. T is in days, so T is a time, so that would be an 8 right here. And you're looking for the amount after 8 days. And then you type that into your calculator and you can get the answer. And there's no logging both sides or anything like that. 3.5171. And milligrams. Okay, let's turn the page. We'll skip this one today. Maybe we'll do it another day. And I want to look at the one below it. This one. El Cajon. I've been there before. Population of El Cajon. Using the data in the table below and assuming the growth is exponential, when will the population of El Cajon surpass 150,000 people? So in 2000, the population was about 94,000 people. In 2011, the population was 99,000 people. So when will the population get to be 150,000 people? In what year is the question. So to do this, it's different than the ones we've done so far in class. We can't use those first two formulas that I gave you. We're actually going to use a formula from way back in the first lesson, exponential growth. An exponential growth formula or function is y equals ab raised to the x. So we have to use this function, and we have to figure out what b equals. So we have y, a, b, and x. B represents the rate of growth of El Cajon. So we're not told in this question what percent is the population increasing. All the other questions, we were able to figure out what the rate was because they told us what the rate was. But this one we have to figure out the rate. So we don't know B. The initial population, A, would be 94,869. That's the initial, that's what we're starting with in 2000. X is the number of years that have passed. So 2011 minus 2000 is 11. And the population after 11 years would be 99,478. So we can use this formula to say 99,478 equals 94,869 times b to the 11th. And we need to solve for b, the rate that El Cajon is gaining people. So if we divide both sides by 94869, then we'd have b to the 11th equals, let's see what this is, 99,478 divided by 94,869 is 1.0486. And now we have to solve for b. So to solve for b, you would do the 11th root of 1.0486 equals b, which on the calculator, the 11th root button, you would do 11, and then under math, number 5, and type that number 1.0486, and I'll round it just to make it a little faster, 1.0043. So that's your b value. So now you can actually find when the population will be 150,000 using this formula again, this one right here. So we would have 150,000 equals the initial population, 94,869, your B value that we just found, and you're solving for a time. And see if you could solve that equation. So at this point, we divide both sides by 94,869. Divide this, so that's going to divide out. We would get 150. 150 divided by that, which is, so we get 1.5811. You'd log both sides, you have log 1.5811 equals, when you log the right, you bring the t out in front, t log 1.0043, and then you would divide both sides by that log 1.0043. So you have log 1.5911, enter, divided by log 1.0043. So 106.8, if we just round to one decimal place, 106.8. And that's years. So it's going to take 107 years for the small Southern California town of El Cajon to have 150,000 people. Now, to talk about China, Beijing has 13.6 million. So El Cajon has El Cajon has 99,000. Beijing in 2011 has 20.2 million. So there's a lot of El Cajons that could fit in Beijing. But we'll have to do this later since our time's running out. Thank you for watching the video.